Hi there, everybody. It's now time to move on to the beginning of the real grade 10 science. What we're going to do today is we're going to start with lesson 1, the structure of the atom. There are three basic learning objectives. You want to outline the changes in the model of the atom over time. It certainly didn't get to the model we have right now overnight. We're going to go through a few scientists and how they contributed to the model of the atom, every time kind of getting a little bit closer, a little more precise. And at the end, though, I would ask that you can associate a name with the model or the contribution to the atom. So these are your three objectives. Let's move on. Two of the earliest were what you can see right here. You have Aristotle, and he's one of the earliest scientists who tried to answer, like, what is matter? A very, very simplified approach. He actually believed that all matter was made of earth elements, fire, earth, and air. Well, it didn't prove to be right, but that's one of the early contributions. Then you move on to Democritus, and I'm sorry if I pronounced that wrong. He had a very interesting idea. He said that all matter was made up of tiny particles that could not be divided into smaller pieces. Well, turns out that's pretty much correct. And as you can see, he called these by the root word for atom. So already we're on the right track towards an atom. I do like this, though, how he knew right away that, or at least he hypothesized that it was a particle that could not be divided. Let's move on. This right here now for John Dalton is where we see the first real concrete evidence of the atom. I would ask that you know who Dalton is, what he contributed. As you can see right here, there are a few points to this, and I'm sure we went through this in the grade 9 review, and you've seen this many times. It is in your textbook. Elements on the periodic table are made of small particles called atoms. Okay, I like this one. It says that atoms of a given element are identical in size, mass, and other properties. So basically, if you had an atom of, let's say, sodium, that's Na, and you had another one, they should be exactly the same. They should have the same size, the same mass, the same properties. You can see here that Dalton also agreed atoms cannot be subdivided, created, or destroyed. Atoms of different different elements combine to form simple compounds. Now, we are coming to this later, believe you me. But this was really awesome because he determined that if you take, let's say, atom A and you add it to atom B, well, you should get a compound of AB. That's very simplistic, but on the right track. Chemical reactions, atoms are combined, separated, or rearranged. Again, these are more into what we're coming into, but this is a very nice model. J.J. Thompson. J.J. Thompson is very important because of his discovery of the electron, the negative electron. Please, we're going to know that, but the negative electron is an important one. Thompson, his model was wrong. It was called the plum pudding model, and you can see it right here. Basically, what he thought is there was a big mass, this spherical cloud of positive charge with electrons kind of embedded within. Now, that wasn't the right model, but his contribution of the electron is extremely important. The electron will play a huge role in our bonding. It'll play a huge role. You move into chemistry 20, chemistry 30, physics. So this is a big discovery. Next you have Rutherford. Rutherford carried out a very famous experiment called the gold foil experiment. Now, I am going to link a YouTube video of this, but essentially, if I can sum it up here very, very quickly, what Rutherford did is he shot alpha particles at a gold foil, at a piece of gold foil. Essentially, it was gold, a really thin foil of gold with atoms in it. And what he did is right here you can see the particle, it's called an alpha particle emitter. And what he did is he shot positively charged alpha particles towards the gold. Now it turns out that most of the positive alpha particles went right through with no deflection. But every once in a while, one would be deflected at a huge angle. What this led to is that he determined that most of the atom is empty space, except at the very middle, there must be a dense positive center called the nucleus. So essentially what he's saying here is, let's just pretend here's the atom. Most of it's empty space, except in the middle. And in the middle, that must all be positive. Because if you think of it, if the alpha particle is coming through, that's a positive charge. When it hits the positive center, as we know, positive charges don't want to come together, so they would repel in various directions. Anyway, the point is, this led to the discovery of the nucleus and the positive proton. You may want to watch this video for some more information, but you just have to remember it was a very famous one. You'll do some more of it in Chem 20, but it is a substantial experiment. To summarize what Rutherford came up with, this is his atomic model. We're getting a little bit closer, but not exactly on the ball just yet. So here you have the atom. As you can see, most of it is just empty space. And what he believed is that in the middle you have your dense positive nucleus, and you have electrons floating around the space. And this would explain why when he shot the alpha particles through this model, most of them went straight through because there was nothing to hit. There was only some that came through towards the positive center. This is a positive particle towards the middle positive. It's going to try to avoid it and repel this way. So this is his model of the atom. Now this is extremely important. This is Bohr's atomic model. He proposed that electrons surround the nucleus in specific energy levels. So you have level 1, level 2, level 3. He found that, let's say an electron was in level 3 and it drops down to level 2, it will emit energy or light. And this actually is proven to be true. You'll learn about this more, I believe, in physics. Anyway, the fact that we have electrons in these energy levels was a huge development and helped us understand why bonding occurs. So as you can see right here, you have a positive nucleus with the negative electrons in energy shells, energy levels around the atom. So where do we stand today? We have the quantum mechanical model of the atom. This is the model that we accept today. So here's what we got. You have the this should be the nucleus, I'm sorry. Inside of the nucleus, you have positive protons and you have neutral neutrons. And then you have an electron cloud, which contains the electrons in different energy levels. In other words, if I drew it myself, I would put this as the nucleus. Inside the nucleus, you're going to have positive protons and neutral neutrons, various numbers. And the electrons are going to orbit in different energy levels. That's the given model of the atom that we have right now. This concludes the end of lesson 1. I will assign some review or questions to answer, but the purpose of this lesson basically was to let you understand how the model of the atom changed over time.